Hello, everybody. Welcome back. It's Mo again. Well, this lecture we're going to be looking at is what is LACP? What is PAGP, which is like an ethereal channel? What does that mean? All right, watch this. Look what I'm going to be using over here. I'm going to be using a layer 3 device, which is a multi-layer switch. So I'm going to get two of them. Here's one over here and one over here. So this is going to be my first one. Watch this. Let's say this is switch one, or let's say MLS multi-layer switch one, and this one is multi-layer switch two. All right. Power each one of these. So I'm going to go ahead and click on the power itself. And same thing on this one over here. And this is powered right over here. Now, let's say this. If I just put one cable from one switch to another, what speed am I getting? I mean, all of these are gigabit ports, which means I only get 1 gig, just 1 gig. What does that mean? For example, let's say I have a lower level switch right over here. Okay. And I have another one right over here. All right. Let me move these up over here. And let me move this up over here and this one right over here. And let me just get, you know what, just one client for now. And let's say we have a server on this side. Let me make some connections. So I'm going to connect to port one, right? And I'm going to connect this to port two. All right. So this is one, and that's another one too. So each one is connected to its own port itself. Now, what I'm going to be doing is the following. Watch this. I'm going to have a connection from switch to switch and switch to switch. Why? Because normally I want to have heavy traffic going on over here. Remember, this is like a switch and a router. So I get myself a crossover cable, and I'm going to say from gigabit 02 to, let's say, gigabit 1/0/24. And same thing over here from gigabit 02 to the same one, 1/0/24. So I want to make sure that this device will reach this device over here. I'm just putting one. Let's say there's hundreds from one switch to another and hundreds of servers. I want this to be heavy traffic, which means the throughput will be very fast. If I just go ahead and I put, let's say, gigabit 1/0/1 to 1/0/1, and I just have one, the speed over here is 1 gig. Okay, you're gonna tell me, well, Mo, let's put another one, right? From gigabit 102 to 102. Well, do you remember in our previous lecture, we saw that Spanish tree algorithm detects which one is the root bridge and which one is not. So technically speaking, only one cable can be used. And you're gonna say, well, can we go ahead and just put more? And let's say from 103 to 103, and 104 to 104, and 105 to 105, and 106. And you'll see why I'm doing this, to 106, and 107. And watch this, to 107, and then 108 to 108. So this is what I have. Why did I stop at 8? You'll see why in a moment. Let me fast forward. Oh, so only one port is used. The other ones are used there in case of a backup. And the reason why is because there's actual switch loops. So information doesn't go in a circle. There's no broadcast storms. That's what we've been talking about earlier. What I want to do is different. I want to combine all of these cables acting as one so I get more throughput. This is like NIC teaming in Windows, like each one is 1 gig. Right now, if this one talks to this device, it's only going through 1 gig. How about if I can make all of them acting as one cable? So all the physical cables are acting as one logical cable, which means the speed will be 8 gigs from one switch to another. Imagine if each one was 10 gigs, then the speed will be like 80 gigs from one side to another. I mean, we're talking about like a data center, a cloud service provider, an ISP, and more. So what I want to do is the following. If I go to this switch, and let me just change the host name over here, right? The host name is I'm going to be changing over here. So I'm going to say host name, let's say multi-layer switch one. All right. And this one over here, the host name is multi-layer switch two. So let me say no to the setup mode, and I'm going to change the host name to multi-layer switch 2. So I have multi-layer switch 1 and I have multi-layer switch 2. Okay, well, if I go ahead and I do so, remember the spanning tree VLAN, I only have one VLAN, only one port is going to be in forwarding mode, which is port 1. Ports 2 through 8 are going to be in blocking mode. Forget about port 24. Port 24 is hooked up to this laptop. I go to this device over here and I do show spanning tree, all right? VLAN number 1, everything is in forwarding because this bridge is the root. This is the root bridge. In other words, all the ports are actually in what? In forwarding mode itself, right? We saw that based on the election in our previous lecture, right? So that's one thing to keep in mind. So all the ports over here are actually up and running. And this defeats the purpose. Why would I put 8 cables? Well, I want to set up an ether channel. Now, what is an ether channel? I'm going to combine all these physical cables acting as one so I get more speed. And guess what? If I do this, I'm going to disable the spanning tree protocol. Spanning tree protocol is not going to run at all when you configure LACP or PAGP. Now, LACP, Link Aggregation Control Protocol, works on Cisco and non-Cisco switches. PAGP is Port Aggregation Protocol, only works on Cisco products. Okay, so I'm going to be using both. I'll show you how to configure both. What I'm going to do right now first is this. I'm going to go to the first device, my first switch. I'm going to go to global configuration mode. Before I do that, I like to do this command. Show IP interface brief. What is the name of the interfaces? Okay, all of them are up 1 through 8. Forget about the last one, 24. A host is connected here. All right. Another switch is connected there. All right. That's fine. That's okay. I'm trying to focus on multi-layer switch from one to another to get more speed. I want to combine ports 1 through what? Through actually 8. I only can go up to 8. I could put 8 together acting as one. That's the rule. So watch this. Global configuration mode. And then I do interface range gigabit Ethernet 1/0/1 to what? 8. Let me ask for help. Okay. Oh, there you go. Channel group, port bundling. Okay, there you go. I could use also the channel protocol, but I'm going to specify the protocol in a moment over here. So I'm going to say channel, right? Watch this. Channel group and come up with a group number. Let's say 1. And look at this mode. What are you using? Are you using LACP or are you using PAGP? First, I'm going to use LACP. So one side has to be active and the other side is passive. I cannot have both sides as what? As active. So I'm going to say mode, and one side is active, which means that's going to be sending. The passive is going to be receiving. I'm going to say active. So mode is active, and I'm going to press enter. Okay, this is fine. All right, shut down, no shut, and I'm going to do a reload, and press enter. And do you want to do a reload? It says, well, you know what? I want to make sure. Do you want to save? Because I didn't do WR, I'm going to say yes. You see this? It helps you. All right. So what I'm going to do is I'm going to minimize this one over here and I'm going to go to my other multi-layer switch. And look at this. If I do show, watch this. If I do show spanning tree, VLAN number 1, it says listening and learning. We saw that. But you see the cost is 4. Remember when you see the cost is 4, that means it's 1 gigabit per second. Look what's going to happen now. Config T, and I'm going to do interface range gigabit Ethernet 1/0/what? 1 to what? 8. And I'm going to do channel group, the same group number, mode, and I used active on the other one. This one's going to be what? Passive. And I'm going to press enter. Then I'm going to do shut, and I'm going to do no shut. Then I'm going to do what? WR, and then do a reload. And now I'm restarting the actual device. So I'm going to fast forward. Okay. Wow. Everything is green. Spanning tree protocol is not running right now because everything is actually what? Green. So if I go to this device, I give it an actual IP address. Watch this. 192.168.100.100. And I give this device 100.200. All right. Watch this. 192.168.100.200. And let me close this and close this. So if I open this and I go to the command prompt and I say ping with a negative T, 192.168.100.200. And look, I'm getting a reply. I'm going to leave it ping and this is continue to ping. This is perfect for troubleshooting. So I'm going to minimize this. I'm going to go to my first multi-layer switch. There you go. Port channel was created. Okay, nice. This is a good sign. So spanning tree VLAN number 1. I don't see the rest of the ports. Where are they? Oh, the cost got minimized. It's more than 1 gig. It's shared. It's a shared bandwidth. I'm sharing all the cables acting as one. So right now, guess what? I'm using 8 gigs from one switch to another. And as you see, it says port 1. If I do this, show EtherChannel, ask for help, and say port channel and press enter. Look what it tells me. Oh, okay. You're running LACP, and on this side, everything is what? Active. And that's how long it's been up and running. All right. Okay. So let me go to my other multi-layer switch over here and do what? Show spanning tree VLAN number one. Okay. Same thing. Port one. The cost is 3. This is good. It's shared. It is shared as you see. There's no root bridge. There's no non-root bridges. There's no spanning tree right now. I am disabling the spanning tree algorithm when I set up an Ether channel. Okay. Show Ether channel. And then I'm going to say what? Port channel. And I could see, oh, this side is running passive, accepting the other one is active. All right. So let me do show Ether channel and look at this other commands. I could be looking at what my summary itself and enter. It tells me which ones are actually used, which ports are used. What am I using? Okay, you're using LACP. Okay, this is perfect. So right now I'm disabling spanning tree protocol. This one is still pinging. This one is 100.100. And let me go to the command prompt over here, and I'm going to say ping negative T 100.200 and enter. See this? I have this right over here. Okay, okay, good, good, good. Let me go ahead and remove a cable. Remember when I was doing this with the spanning tree? If I remove it, it takes a few seconds. Watch this. I'm going to remove one cable. Did I lose any ping connections? No, you did not. You know why? Because all 8 are acting as one. The only difference is the speed will be slower. I go back over here, still pinging. All right, no problem. All right. Let me remove another one. Let me remove another one too. And look at this right now. I'm not losing any packets at all. I could still have a guaranteed delivery from one side of my network to the other because I set up a port channel over here using LACP, which works on Cisco and non-Cisco what switches. I could have done the same lab with a 2960, but if you notice, all of them are fast Ethernet. I'd rather use a multi-layer switch. It's the same command. You cannot go up more than 8. I go down over here on this one. See this? And it tells me, okay, you know what? When I do this, it tells me some interfaces went down. Does it affect anything? No, it does not. Connection still actually goes through. This is perfect. Okay, let me remove another cable over here. So let me cancel this because it looks like the server is actually highlighted. So let me cancel this and remove this. So now when I take a look at this, it's like, okay, another interface went down. Okay, but did I lose any connection here? No, you did not lose any connection. Did I lose any connections here? No, you did not lose any connections at all. Okay, let me remove another one. Watch this. So I'm going to go ahead and remove another one. Now I have how many cables? 3 cables. Did I lose connection? No. Let me remove one more. So watch this. Okay, I have 2 cables now. Did I lose connection? Of course not. You're not going to be losing any connection. The speed is going to be different. Okay, let me go back over here. It tells me all of these are actually gone. Show spanning tree VLAN number 1. Okay, it says the cost is 3. Look what's going to happen now. I'm going to remove one cable over here and show you. Okay, one cable's gone. Only one is there. Did I lose connection? I don't care. 7 cables crashed. Something went wrong. I do not care. My connection is still actually there. This is perfect. If I go back over here, watch this. Show Spanish tree VLAN 1. You see, I can still see that it's actually shared. What I could do is I could just go back, start putting the cables each one at a time. So 3 to 3, 4 to 4. You see this? Building this network again is going to be slower, but no downtime. Nobody's going to complain. I cannot reach from one side to another. This is fault tolerance. Okay, in case one fails, I have another one that is actually up and running. So now I'm running a smooth network over here. Okay, so this is actually smooth. So this gets done. And if I check over here, did I lose connection? No. Did I lose connection over here? No. I did not lose any connection at all. So connection is not gone. On the Cisco packet tracer, tells me it's up. Okay. WR, show Ether channel. Then I would actually do, like, let's say summary. I could see it's actually there. All right. I may have to actually what? Just reload. Just with a Cisco packet tracer. Fast forward and everything is going. You see that? Everything is perfect. This is nice. This is LACP. All right. What I want to show you in our next lecture, PAGP, same commands, is just a little of the terminology is different, but PAGP is only from Cisco to Cisco. So we'll see you folks in our next lecture. Bye now. Everybody, welcome back. It's Mo again. In this lecture, we're going to be looking at this PAGP, Port Aggregation Protocol, which means it works only from Cisco to Cisco. What I'm going to do is this is the same topology that I had before. I want to wipe everything out. So remember, I could do right erase. This erases everything. Then I could actually reload. I'm going to do the same thing. I'm going to go to the switch, right erase, right erase, and I'm going to reload. There we go. Nothing is there at all. Fast forward. Oh, it's going back to the spanning tree protocol. You see that? All right, nice. So watch this. Let me go back over here and first of all change the host name on this one to multi-layer switch one. Host name is M multi-layer switch one. All right. And this one over here is multi-layer switch two. So I'm going to do no and then enable global configuration mode, hostname, multi-layer switch two, just like this. So what I'm going to do right now is this time I'm going to configure PAGP. So I'm going to go back over here and I'm going to say interface range gigabit Ethernet 1/0/ what? 1 through what? 8. See that? Channel group, same thing as before. All right. One, remember, I could add up to 8 only and mode. And I'm going to say what over here? I'm not going to use LACP. I'm going to use PAGP. So one side is auto, the other side is desirable. So I'm going to make this as what? Auto, enter, shut. So one side has to be one, the other's the other. No shut, do WR and do reload. All right. Just like this. And then I'm going to go to this multi-layer switch two. And I'm going to press enter. So I'm going to go to global configuration mode, interface range, gigabit Ethernet 1/0/ what? 1 to where? To 8. And I'm going to do channel, same thing. Group one mode. Remember the other one was auto? This is what? One is auto, and the other one is going to be what? As you see, desirable. So desirable and enter. So look, port channel one was created, right? I mean, let me do shut first of all and do no shut. I like to refresh it and then do WR, then do reload. There you go. Okay, let's take a look. This will also disable my spanning tree, right? Why will it disable my spanning tree? Because I set up an Ether channel. Okay, connection is on. You see this? Okay, good. Let me go to this multi-layer switch over here and do show what? Let's take a look and show Ether channel. And let's ask for help. Port channel. Oh, you're using PAGP. Okay. All right. So if I do show Ether channel and I say summary, it tells me that I'm using PAGP. All right. I go to this side and I do the following show Ether channel and I do what? Summary, first of all, and I can see, okay, you're using PAGP. So instead of summary, and I put a question mark, I do port channel and enter. Now I can see this side is desirable, which means accepting the connection itself. Well, show spanning tree VLAN number one, and I can see port channel one, it's in forwarding mode, and the post is 3, which means it's higher than what? 1 gig. It's actually 8 gigs right now. And look, it's shared line, which means I'm combining all these physical cables acting as one, but I'm using what? PAGP. So connection will still be on. In other words, if I go ahead and I remove the X over here, and here, and here, and here, and here, I'm not going to lose connection. Why? Because all of them are acting as one logical. So all the physical cables are bundled into one logical interface going from one to another. And then I go back over here and the reply is actually there. So everything looks good. So if I go ahead and I put my cables back, same thing, port 4 to port 4, port 5 to port 5, okay, this one looks like we went to port 6. Let me remove this and get the cable again. So port 5 to port what? 5, port 6 to port 6, port 7, right? To port 7, then port 8 to port 8. You see that? Just like this. I'm back in what? I'm back in business. There you go. Right? So this is actually good. As you see, sometimes in the Cisco packet tracer, you may have to do shut, no shut, do WR, save your configuration, reload because I see one of them is not up. Reload. It's just something with a Cisco packet tracer. Power cycle, fast forward, everything is green. I'm back in business. All right. So this, what I showed you is PAGP, similar to LACP, but LACP works between Cisco and non-Cisco. It supports all vendors. PAGP is only for Cisco, only works on Cisco products. That's what I wanted to show you in this lecture. So we'll see you folks in our next lecture. Bye now.